Okay, so you can see I've got my setup here with my 7 glasses, and then I have my assortment of items, substances, and I'm going to add to the water. So our first up is pepper. So I'm going to start off with the pepper. Add just a little bit. We don't want to go too crazy here. Add a little bit of pepper. And then you can kind of see it's just sort of sitting there on the top. It is settling and kind of falling down to the bottom a little bit there, as you can see. And I'm going to give it a stir. So I'm just going to use a plastic knife here to stir. And you can see it doesn't really mix in at all. You can still see the individual little flecks of pepper. There's still kind of a bunch sitting on the top, and it's really just not mixing in at all. Even if I add a little bit more, I mean, you can even see right now, I don't even have to add more. You can see there's a nice little clump of pepper forming on the bottom there. So this would definitely be a heterogeneous mixture. In order to separate this, if I pour this through a filter, I would get the pepper in the filter, and I would be left with the water separated from the filter. I mean, separate from the pepper. Okay, next one up is our salt. So I've just got some plain ordinary salt here. You can add, again, just a little bit. We don't want to add a lot. We don't have a ton of water in here. Give that a good little stir. And you can see it just about all dissolves. There's a tiny little bit there at the bottom that didn't dissolve. But for the most part, it's all dissolved. We can see through it. So I would call this a homogeneous mixture, a solution. And on the solubility scale, you know, it's pretty well dissolved in there. I probably would give it like, if you know, 1 is insoluble and 5 is very soluble, I'd probably go 4 or 5, because I mean, I really don't see anything left in there. It's all pretty well dissolved. I think those little bubbles that you're seeing are more air bubbles than actual salt crystals. All right, so next on up, after we have our salt, is going to be our iced tea mix. So I just have some iced tea mix that I'm going to add in. Again, just a little bit. You don't want to get too crazy because I don't have a lot of water in there, and we don't want like a, you know, if I add too much of the substance, then the mixture might become too saturated and it won't dissolve anyway. You don't want to get weird results because I just added way too much, but it looks good. And so you can see all of the iced tea mix has dissolved. I don't see any left in there. It's pretty well evenly mixed. Again, I think the little bubbles that you're seeing are probably just little air bubbles. This, even though it's not totally see-through, I can still see through it pretty clearly. Like I can see the salt container through that solution. So I'm going to say this is a solution, homogeneous mixture. So for the salt water, and this was the salt water, for the iced tea mix, for these solutions, you know, to separate these out, all you would have to do is let them evaporate, and you'd be left with a chunk of iced tea mix at the bottom, and you'd have the water, you know, be evaporated into the air. Okay, so next on up is sodium bicarbonate, also known as baking soda. See, even on the package of baking soda, it says bicarbonate of soda. So we're just going to add a little bit. Oh, for the solubility rating on the iced tea mix, I probably would go again 4 or 5 because that dissolved pretty well. I didn't see anything really floating around. All right, so just a little bit of baking soda. Add that in there. Give it a really good stir. And you can see it's all dissolved. I don't see anything sitting at the bottom. Looks like it's all evenly mixed up. We can see through this. So this would be another example of a solution, homogeneous mixture. And again, to separate that, we would let that evaporate, and we would have the baking soda back at the bottom there. All right, moving on down the line, we've got our vegetable oil next. So you could use vegetable oil, you could use corn oil, you could use olive oil, you could use avocado oil, whatever kind of oil that you might have, peanut oil in your house that your mom or dad probably uses for cooking, that's what you want to use. And for this, we're going to use a little bit more just so you can see the effect better. So I'm going to pour maybe like a 1/4 of a cup, maybe a little more, of the oil into the cup. And you can see it's sitting right on the top there. If I give it a really good stir, a little tornado effect going on here. But you can see all those little bubbles, and you can see that layer of oil starting to form again on the top of the water layer here. So this would be a heterogeneous mixture. It's unevenly mixed. You know, we'd have to shake this up. You know, this would also be called a suspension. We'd have to shake this up before we would use it if we were, you know, using this for something to get it mixed together again. And then to separate this, you could evaporate this. You could pour it through a filter. If I pour it really carefully, I could probably pour off that oil layer first and then just be left with the water underneath, because they are two separate layers. And then this would be, you know, insoluble. Anything that forms a suspension, you would consider like a 1 or a 2 on that solubility rating. Like it does not dissolve. So probably even just a 1. Okay, after the vegetable oil is some sugar. So I have some sugar here in a bowl. I'll grab my next empty cup. A little bit of sugar, not too much. Stir that in there. And you can see it pretty well all dissolves, pretty much all gone. It's a little bit sitting on the bottom. But if I keep mixing that, I'll bet I can probably get that to all dissolve into the water. So again, we're going to say this is a suspension solution. It's evenly mixed. You don't have layers. You don't really see the sugar particles except for the little bit that didn't quite dissolve yet. We can see through this and separate this out. We would let the water evaporate, and then we'd have the sugar back. So that's pretty evenly mixed. You don't see any layers. You don't see large particles floating in there. So we would consider this to be a solution, a homogeneous mixture. Solubility rating, probably, you know, again, 4 or 5. Okay, our last combination, figure out which cup I hadn't used yet. Our last combination is your pick your own. So for my pick my own, I went with cinnamon because that's something that I had handy in the pantry. So I'm going to add in a little bit of the cinnamon, and you're going to see what happens. So depending on what you picked, you know, your results may vary depending on what you decided to add. If you added sand, maybe, you know, you get a different result. You can actually see the cinnamon sticking to the sides of the knife in here after I dipped it through the cinnamon layer that was on top of the water. So this would be very insoluble. This would, hi, Emma. This would be a heterogeneous suspension. I'm sorry. Yep, heterogeneous suspension. You can see there are some pretty large chunks of the cinnamon still floating around in there, so it did not evenly mix. And to get this to separate out, I would probably just pour this through a filter, and that would catch the cinnamon particles. And I would have the cinnamon back separate from the water. Again, depending on what you chose for this last one, you would get maybe some different results. So that's all the mixing substances. And then for that last little like extension experiment, I'm going to grab a separate empty glass of water, and I'm going to get some more pepper. This time I'm going to put a little bit more in, just instead of a sprinkling, I'm going to kind of coat the whole surface. If I can open up the container with one hand, there we go. So I'm going to kind of dump on some of the pepper, and you can see it's just kind of sitting on the surface there, and that's because of that surface tension. Some of it is falling down to the bottom because I did kind of dump on a lot. But you can see like there's kind of like a layer here of the pepper. And that's because of surface tension. You know, the water particles are sort of forming like a little layer that the pepper is sitting on there. So I'm going to add a couple of drops of dish soap, and let's see what happens. Dish soap kind of acts as an emulsifying agent. And you can see as soon as the dish soap hit the surface of the water, the pepper all kind of moves around. Drop over here. A couple drops. You can see as soon as the dish soap hits the water, it's kind of like moving the pepper around. All right. You can still see I've got some chunks of pepper on the bottom, kind of evenly mixed, kind of like all over. And give this a really good stir. And you can see that I've got pepper all mixed throughout the glass here instead of this from before where the pepper's kind of sitting at the top and it's kind of sitting at the bottom, but it's not really too much in the middle. Now you can see there's pepper all throughout here. Again, this is still considered a heterogeneous mixture. It's still a suspension. And to separate this out, I would have to pour it through a filter, but the soap acts like as an emulsifier, and it kind of binds and holds the holds the water particles and the pepper particles together. All right, now clean up your mess and have a great day.